Hi, child. Welcome back to this is section 1.1 in topic 1. Today we're going to talk about domain and range and how to find the x and y intercepts. The very first thing we need to do is get some vocabulary out of the way. See if you guys remember what these things actually mean and how we find them. All right. So the very first thing we're going to talk about is what we call interval notation. All right, and I'm going to abbreviate a little bit of it as we go. So if you are concerned about what they are, just ask. But interval notation is what we're going to talk about first. So you guys have seen this before, whether or not you remember it, we're about to find out. So one example of this would be something that looks like this. Let's say we had a range of numbers from 4 to 12, and we put brackets around them. Okay, so that means any number from 4 all the way up to 12 would be an answer for whatever the problem is that we're working with. So 5 would work, 6 would work, 4.5, 4.7, 8.6, whatever it might be. Another option that you might see is this symbol, which we call infinity, which means it goes forever and ever and ever and ever and never stops, from negative infinity to 2, but this time we put parentheses around them. Okay, so that means a couple of different things. So the very first one, whenever you see a bracket, if you see a bracket around a number, that means it is going to be a closed circle. All right, so the circle is going to be filled in. So it's going to look something like this. Right? It's not going to be like an open circle. So it's going to be a filled in circle. Whenever you have infinity, whenever you have this symbol, kind of like the sideways 8, that is always, 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 always going to be a parenthesis. Because infinity is not really a number. It's an idea. Always use that for infinite. Okay, so whenever you see infinity, you are always going to use a parenthesis. All right, and if the number is not included, so if this would also be used for an open circle. So an example of that would be a circle that's just not filled in. Okay, so we have closed circles, which are filled in, and open circles, which are not filled in. All right, the second thing we are going to talk about is what we call domain and range. So domain, which I hope all of you remember this because I know you did it in Algebra 1, you probably did it in Geometry too. Domain is all the x values of the function that we are working with, all the function or the graph or whatever it might be, all of the x values. And the range is all the y values. And if you remember, on an ordered pair, x values come first and y values come second. So all the first numbers are the x's, all the second numbers are the y. So all the first numbers are the domain, all the second numbers are the range. So that will take care of the first problem, first example, which we're going to do right now. Okay. So it says, what are the domain and range of each function? Write the domain and range in set builder and interval. We are not going to worry about set builder. We are going to focus on interval notation for all of it. Okay. Now, the easiest way for us to do this, we haven't really talked about parent functions yet, which we'll get to. If we knew that, this would be even easier. But at this point, all we are going to do is graph these. Okay. So we are going to use Desmos. If you are not familiar with Desmos, if you have never used it before, there is an app on your phone that you could get. In addition, on my Canvas page, right below the modules, you will see where it says Desmos Calculator. Okay, and you can go there and you can type this exact problem into Desmos, and it will graph it for you. And if we graphed this, if we were to graph this in Desmos, it would look like this. So it would be a V shape because it's absolute value. Okay, and it would be moved over 4 to the right. 4 places to the right is where the vertex moved to. So that's what our graph would look like in this case. Okay, and then it wants us to find the domain of that and the range of that. So the domain, as we just talked about before, is all the x values of this graph. And the range is going to be all the y values. So we're going to do the domain first. So all the possible x's on a graph, the x goes side to side, the y goes up and down. So all the possible x values going side to side. If you notice, this graph has 2 arrows on the end. Okay, that means that it is going to go in this direction forever, and it is going to go in this direction forever. It's never, ever, ever going to stop. Okay, so no matter what number you pick on the x, let's say you pick -10, which is way over here, that graph eventually is going to get to -10. If you pick +100, which is way over here, this graph eventually is going to get to +100. Okay, so that means it will never ever stop. So therefore, our domain is negative infinity to positive infinity because it will never, ever, ever, ever stop. Okay, it just keeps going forever and ever and ever because of those arrows that it has. Now, the range is going to be a little bit different because the range goes up and down. So it goes up. These arrows means it goes up forever, right? It'll never stop going up, but it only goes down so far. Okay, so the lowest point that this graph gets to, this point right here, that's as low as the graph gets. That value is 0, right? Because it's right on the line. So that means the range is going to be from 0 to positive infinity. Positive infinity always gets a parenthesis, but if you notice, this circle is filled in. And since that circle is filled in and closed, we are going to use a bracket around that 0. Okay, so that is the domain and range for the very first problem. Okay, so domain and range. All right, the second problem is a little bit different because they give us it's kind of a weird graph that we have. And it's going to look something like this, okay? If you were to graph it, it would cross at 0 and 3, okay? And then it is going to go up to 1.5 and 4.5. So again, you would just type that into Desmos, and Desmos will tell you exactly what those points are, okay? And then it goes like this, and then it goes, whoops, I missed the dot, but hopefully you hit your dot. That's not the best graph, but you know, what are you gonna do? So there's our graph, okay? And now we're gonna do the same exact thing that we did on the last problem, okay? We're gonna find the domain, and we are going to find the range of this. Okay, so again, domain is all the x values. So from side to side, only look side to side. Don't worry about up and down. And again, there's 2 arrows on each side. So it's gonna go this way forever, and it's gonna go that way forever, meaning it never, ever, ever, ever stops. So it goes from negative infinity to positive infinity. And the range is the up and down part. So that's the y value. That's up and down. So the highest this gets, I know it's kind of hard to tell. On your Desmos, you'll be able to see it easier. But the highest this graph gets is 4.5. So it goes from 4.5, and then it goes down forever. It just keeps going down, never ever stops. So from 4.5 to negative infinity, because we are going down. Since we go down, that's negative infinity. This one was going up, so it was positive infinity. Okay, so it's negative infinity if it goes down on the range, positive infinity if it goes up. All right? So that is domain and range, and that is an introduction into interval notation. Interval notation is what we're going to use just about the entire year, so you'll become very, very familiar with it. Okay? The next thing we are going to discuss is the x and y intercepts. And again, we are going to do this using Desmos or using a graph, all right? So first things first, what is the x-intercept? Okay, x-intercept, for those of you that are into sports, if you intercept a pass in football, right, the other team gets it, so they cut it off, right? It's where it intersects, where the person has intersected the pass. The same idea here, okay? The x-intercept is the point where the graph crosses x-axis. And if you cross the x-axis, if the point is on the actual x-axis, that means that our y value has to be 0. So it's wherever y equals 0. Okay, so if you had a graph and you just had a bunch of points, wherever y was 0, that is what our x-intercept would be. It's going to be the exact same thing for the y-intercept. So the y-intercept is going to be the point where the graph crosses the y-axis. And that means that x would have to equal 0. So wherever the x is 0, that is what we call the y-intercept. Okay? So it's really, really easy to find the x and y-intercept when you're given a graph. Okay, so we're going to find the x and y-intercepts of this equation. And again, we will go to Desmos, And if you are unfamiliar with Desmos, I will be more than happy to show you how to use it and kind of guide you through it. It's very, very simple. You can get the app on your phone. You can use it on the computer, whatever works best for you. So if you go to Desmos and you type in that equation, 4 minus x squared, your graph is going to look something like this. So -2, +2, and 4. And it is going to be in the shape of what we call a parabola. So there is the graph for that equation. So all we need to do is pick out what are the x-intercepts and what are the y-intercepts. So the x-intercepts in this case are where it crosses the x-axis, right? So that would be this point and this point. Wherever it crosses is it. So we are going to say that the x-intercepts are 2 and -2. That is where it crosses. And that would mean that the y-intercept is where we cross the y-axis, which would be that one up top here in green. Kind of hard to see my colors, but up there in green would be the y-intercept. So that would be y equals 4. So we have our x-intercept and we have our y-intercept. And there is my first video for you of 2020 to 2021. If you have any questions, if you're lost about anything, please don't hesitate to ask. I will be more than happy to help you. If not, I will talk to y'all soon. Bye.